Hi, welcome to NVIDIA GTC 2020, our first kitchen keynote. I'm coming to you from my home in California, and I hope all of you are well and sheltering safely at home. Before we start, I want to take the opportunity to thank all the brave men and women who are fighting in the front lines against COVID-19. The nurses, the doctors, the truck drivers, the retail clerks, the warehouse workers, all of the people who are keeping the world going while we're sheltering at home. We're also doing our part to fight COVID-19. Scientists and researchers around the world are racing to find a vaccine for COVID-19. We're working with them across the entire spectrum, from containment, mitigation, treatment, to eventually tracking and monitoring. Oxford Nanopore, for example, was able to sequence the virus genome in just 7 hours using our technology. And working with Plotly, we can do now real-time infection rate analysis. And with Oak Ridge and Scripps, we were able to screen 1 billion drug compounds in a day versus a year. The team at Structura, NIH, and UT of Austin used CryoSpark to reconstruct the 3D structure of the virus spike protein. NIH and NVIDIA built an AI model to classify COVID-19. KiwiBot built a robot to deliver medical supply autonomously. And Whiteboard Coordinator built an AI system to automatically measure and screen the elevated body temperature. Researchers and scientists applying NVIDIA's accelerated computing to save lives is the perfect example of our company's purpose. We build computers to solve problems that normal computers cannot. We address applications from computer graphics, scientific computing, artificial intelligence, to robotics. And our computing platforms are incorporated into PCs, supercomputers, cloud computers, as well as autonomous machines. We work with scientists and researchers all over the world, and it's a great privilege for our company to partner with them to advance and discover the future. Our amazing creative team made a video to celebrate the great works of these researchers and scientists. Let me show it to you.
I am an explorer. Searching for the origins of our universe. And charting a safer path to other worlds. I am a helper, moving us forward one step at a time, and giving voice to every emotion.
I love you.
I am a healer, modeling the future of medicine. And finding a needle in a haystack when every second counts. I am a visionary, uncovering masterpieces lost to the ages. And finding new adventures in a galaxy far, far away. I am a builder, driving perfection in everything we create. I am even the narrator of the story you are watching. And the composer of the music. And when the world faces its greatest challenge, take it on together. I am AI.
It is truly inspiring to see what is now possible because of accelerated computing. Accelerated computing starts with a specialized processor we call the GPU that offloads the computationally intensive tasks from the CPU. It also includes an acceleration stack. The software is a vitally important part of accelerated computing. The acceleration libraries, the algorithms, the system software, and the optimizations that we develop together with the application developer. The system architecture is also important. It is important for us to be able to optimize the system, whether it's for high-performance computers, cloud data centers, PCs, or autonomous machines. But ultimately, the most important part of accelerated computing is developers. Developers optimize their applications, which increases the performance and the value of the platform, which attracts customers, and increases the installed base, which attracts other developers. The positive feedback system grows, and it is now very clear that NVIDIA's accelerated computing platform is at its tipping point. Over the last several years, two fundamentally new dynamics has happened to take accelerated computing to the next level. The first is the emergence of this new type of algorithm called data-driven or machine learning algorithms. Data processing and the movement of data around the data center is more important than ever. The second is the applications that we're processing now are so large it doesn't fit in any computer. No server, no matter how powerful, are able to possibly process the type of application workloads that we're now looking at. In fact, the server is no longer the computing unit. The data center is the new computing unit. With software-defined data centers and application developers able to write applications that run in the entire data center, it is important now for us to think about optimizing across the entire end-to-end of a data center, from networking and storage to computing, for us to optimize the entire stack, top to bottom, to be able to optimize at the data center scale is NVIDIA's new approach. And I believe that in the next decade, data center scale computing will be the norm, and data centers will be the fundamental computing unit. The importance of high-speed networking and data processing in a data center is exactly the reason why we bought Mellanox. Mellanox is the world leader in high-performance networking. And high-speed networking and high-speed computing go hand in hand. Let me show you what they make. I have one here that I've been cooking for a while. This is a state-of-the-art Mellanox Spectrum 4000 series Ethernet switch. Each one of the ports can scale up to 400 gigabits per second. The entire switch has an astounding 25.4 terabits per second of bandwidth. And what makes this particular switch special, beyond the fact that it's high performance and Mellanox's world-famous low latency, are three characteristics. First, this data buffering architecture that makes it possible to meter the bandwidth across the entire switch so that every port gets a fair and predictable bandwidth. Second, incredible virtualization technology so that you can virtualize VXLAN routing across your hyperscale data center. And third, you could find out exactly what's happening with this new technology called WJH. What just happened? On the other side of the switch is this programmable smart NIC, the NVIDIA Mellanox Bluefield 2, the world's most advanced programmable smart NIC. Bluefield 2 accelerates security and packet processing at line speeds, in this particular case, up to 200 gigabits per second. The networking stack, the storage stack, the security stack is now completely offloaded and runs on one of these programmable smart NICs and what will eventually become essentially a data processing unit. This is going to represent one of the three major pillars of computing going forward: the CPU for general purpose computing, the GPU for accelerated computing, and the DPU, which moves data around the data center and does data processing. No one knows more about networking, storage, and security in a data center than Mellanox. and they are so vital to today's high-performance data center scale computing. I'm so happy that we're officially one company. I want to welcome all of our families at Mellanox to NVIDIA. GTC is all about developers, and developers are all about SDKs. This year, we announced and shipped 50 new SDKs. NVIDIA's SDK is formed in a stack that is represented here, and it's basically 3 layers. The first part, of course, is our CUDA architecture. It is architecturally compatible against the entire installed base of NVIDIA, and this year, we announced the 11th generation of CUDA. That tells you something about our commitment to this architecture, to forward compatibility and backwards compatibility. A CUDA developer who develops on CUDA will know that the entire installed base of NVIDIA GPUs will run that application and run it wonderfully. The next layer is CUDA-X, our acceleration library, our linear algebra library, signal processing library, graph analytics libraries. And this year, we have several new ones. cuDNN 8th version, TensorRT 7.1, which is our deep learning network compiler and optimizer. And then on top of it, we have our market or domain-specific libraries, from RTX, which is for ray tracing, HPC for high-performance computing, Rapids for data analytics, AI for AI, Clara for healthcare and life sciences, Metropolis, our video analytics and our streaming signal AI platform, Drive, autonomous vehicles, Isaac for robotics, and Aerial 5G, one of our latest, for 5G virtual RAM processing. The number of developers on NVIDIA accelerated computing has continued to grow, and it's growing what appears to be an accelerated rate. And this year, we have reached 1.8 million developers. I want to thank all of you for your support. We're committed to continue to advance this platform and to continue our forward and backwards compatibility of our architecture so that your installed base continues to grow. This year, although we didn't have a live GTC, 46,000 developers signed on to watch GTC. 5.5 million developers downloaded CUDA. And we now have over 700 applications that are accelerated. I have a lot to announce this year. We have 4 new applications that are really important that I'm super excited to share with you. We have a new chip that we're announcing, and we have 4 new systems. So let's get started.